Welcome to the deep dive, where we take a stack of sources and research and really just distill it all down to give you a shortcut to being well informed.
And today we are focusing on something critical in all of modern AI infrastructure.
We are. It's all about workflow efficiency. We're diving into a really fascinating comparison study about how large language models manage their external tools.
Right, we're going to be unpacking the before and after of something called the Model Context Protocol, or MCP.
And for anyone listening, if you use AI to, orchestrate complex tasks or even just automate project updates on Slack or Jira, you've probably hit this wall.
You absolutely have. It's the efficiency ceiling.
Yeah.
And it's almost always caused by one thing:
Yeah.
tool fragmentation.
Exactly. So our mission today is to understand precisely how a protocol like this fundamentally changes how an LLM interacts with everything.
Yeah, and we should be clear, this isn't just about making things a little bit faster.
No, it's a total shift in the architecture. It's moving from a clunky, one after the other process to a seamless parallel workflow. We want to give you the mechanism behind that.
You've hit on the central conflict right there. You have these incredibly powerful LLMs. They're brilliant at reasoning and planning.
The brain is amazing.
The brain is amazing, but it's constantly held back by the isolated tools it has to use. The hands, the tools, they just can't coordinate with each other.
And what we're going to do is reveal the specific change that solves that exact problem.
That core problem of tool fragmentation.
Okay, let's unpack this. So to really get it, we have to set the stage. Let's talk about the inefficiencies of the old world, the system before MCP.
Right, so the foundational structure before these protocols existed was basically a series of isolated point-to-point connections.
Meaning the LLM is talking to each tool separately.
Exactly. It's talking to a database, maybe a client like Slack, maybe an email service. But crucially, each and every interaction is a separate, discrete event.
Okay, let's make this really concrete for, for our listener. Imagine you ask your AI to generate a weekly sales report from yesterday's data, summarize the key finding, and then post that summary to the exec Slack channel.
Perfect example. That request immediately shows the problem. In that before state, the LLM starts the first tool call. Get data from the SQL database.
Okay.
When that data comes back, the LLM then has to parse it, hold all of it in its context window, and then start the second tool call, the summarization tool.
And because that second tool is totally isolated, it has no idea why it's getting this data right. It doesn't have the context from that first step.
None at all. And this forces the LLM to manage the output of each tool one by one, sequentially. The LLM becomes this poor middle manager, constantly using up its precious context budget, its memory, just to re-explain the last step to the next tool.
So it's basically saying, hey, I just got this 50-page data set. Now I need you to look at just the Q3 churn rate section and ignore everything else.
Exactly. The LLM is just burning tokens on organizational overhead. It's resending context that the tools themselves should already be aware of.
That just sounds like a massive, massive token inefficiency.
It is. And the sources we looked at, they pointed out some really clear pain points from this. First, repetitive processes.
How so?
Well, if the LLM needs to cross-reference two different data sources, it might end up retrieving the same metadata twice, just because the two calls weren't coordinated.
Okay, that makes sense. And I assume response times are slower.
Inevitably, because of that sequential handling. The whole system is just waiting. It's waiting for tool A to finish, then for the LLM to process that output, and only then can it even start tool B.
And you can see how the final result would suffer too. If the context gets a little garbled or there's a small error from one tool, the next tool just runs with it.
Precisely. And that's where you get the fragmented or incomplete results the study noted. The core issue is that the architecture forces this brilliant LLM into a linear sequential bottleneck.
It's like a genius CEO trying to run a company by sending a separate, long email for every single tiny step.
Perfect analogy. There's no shared meeting space, no centralized dashboard. It's a powerful mind handicapped by its own plumbing.
It's handicapped by the plumbing. But here's where it gets really interesting. Let's transition to the world after MCP. This is where the whole architecture flips.
Right. So in this new architecture, the LLM is still the brain, but the way it communicates, that fundamentally shifts.
It's not talking to each tool individually anymore.
No. It now interacts with all those services, the database, Slack, email, through the Model Context Protocol. The protocol acts as this intelligent, centralized dispatcher.
Okay, so the LLM talks to one thing, the MCP. But how does that solve the context problem we just talked about? Is it just routing traffic?
It's so much more than just routing. The deeper technical function is the key here. The MCP introduces two core functions: API standardization and persistent context management.
Let's break those down. API standardization.
So instead of the LLM having to deal with a dozen different API formats and all the little quirks of each tool, the MCP standardizes that communication layer. The LLM just sends its instructions in one standard format to the MCP.
And the MCP is the universal translator, making sure tool A and tool B both understand their role without the LLM having to hold their hands.
Exactly. And that's where the second piece, persistent context management, comes in. This is the real insight. The MCP maintains a centralized, shared context state across the entire workflow.
So when the LLM tells the MCP, get the Q3 data, the MCP runs the database call.
Yes, but it retains the state of that interaction. It remembers that the data was retrieved, where it's stored, the specific parameters. All of that lives inside this unified communication layer.
Which means when the LLM later says, now summarize the churn rate, it doesn't have to resend the whole data set or re-explain anything.
It just references the persistent context that the MCP is managing.
That must slash token consumption and latency.
That reduction in overhead is the primary driver of the performance increase. You're going from a sequential, memory-intensive process to a context-aware, parallel orchestration. The MCP is the structural change that unlocks everything else. It turns those isolated islands into a cohesive archipelago.
Okay, but if we centralize all the communication, all the state into this one protocol layer, doesn't that create a huge single point of failure? I mean, if the MCP goes down, the whole system grinds to a halt, which sounds even riskier.
That is a very fair question, a critical one. And the source material addresses it by focusing on the robustness of the protocol itself.
How so?
Because the MCP mandates that API standardization we talked about, it actually improves error handling and resilience. In the old system, if tool A failed, it might just give the LLM some weird output.
And the LLM wouldn't know what to do with it.
Exactly. It would cause a cascading failure in tool B because the LLM was acting as the manual error handler. With MCP, the protocol is designed to handle those error codes consistently.
So it's a dedicated quality control layer.
It is. If one tool fails, the MCP isolates that failure, logs it precisely, and can often trigger a recovery mechanism or just fail gracefully, preventing the whole workflow from collapsing. So you get enhanced capability through structural robustness.
That makes a lot of sense. So let's get back to the practical benefits. What's the biggest performance gain you see after you integrate this unified layer?
The biggest shift is the ability to enable truly simultaneous and coordinated action. It's a game changer.
So we're moving beyond sequential.
Way beyond. Before, we had to wait for the database pull, then process it, then start the analysis. Now, the LLM can give the MCP one single complex instruction, and the MCP leverages all the tools to their fullest potential.
Okay, take us back to that sales report example. How does the MCP change that specific workflow in real time?
Right, so you ask for the report and the summary. The LLM sends that complete instruction set to the MCP. The MCP doesn't run it linearly.
What does it do?
It can tell the database tool to begin pulling the data. That's tool A. While that's happening, it can simultaneously send a prep command to the analysis tool, tool B, to set up its environment for the data it's about to receive.
And tool C, the Slack tool.
It can alert the Slack tool that a message is inbound, maybe even start fetching the user avatars or channel IDs it's going to need later on.
So the total time is no longer tool A plus tool B plus the LLM's thinking time. It's now just the time of the longest single task because all the little prep tasks are running in parallel underneath.
Precisely. And that is the core difference between a sequential, latency-ridden process and a truly efficient, coordinated one. It's not just about reducing latency, it's about increasing the complexity the system can handle.
So the LLM itself, it feels smarter and more capable, as the study said.
Yes, it's not because the model was upgraded, it's because the plumbing was upgraded. The LLM is unshackled from all that manual context management.
And I have to imagine this makes adding new tools way easier, too. Scalability becomes part of the architecture.
Absolutely. If you want to add a new visualization tool, you don't have to write custom code for it to talk to every other tool. You just integrate it into the MCP standard.
And because of that unified communication layer, all the old tools instantly know how to talk to the new one.
Exactly. It dramatically lowers the barrier to growth and innovation.
This is such a powerful case study in how architecture really determines capability in these AI systems.
That is. The centralization of interactions through MCP is the engine for systemic improvement. If you zoom out, the entire concept of AI orchestration relies on managing shared context efficiently. Before MCP, context was expensive and temporary. After, it's persistent, centralized, and cheap to reference.
And the conclusions from the sources, they really back this up. This shift moves the whole system into a fundamentally better state.
It does. The final result is a system with massive gains. It's much more efficient computationally and with token use. It's way more scalable.
And more responsive.
Far more responsive. It delivers faster, more accurate results because context is never lost or duplicated.
So what does this all mean for you, the listener?
It means that when you interact with an AI system that's coordinating across multiple apps, you should expect fundamentally better performance, faster responses, higher quality results, and the ability to handle complexity that would have just choked older systems.
The LLM is no longer fighting its own infrastructure.
It's leveraging it.
So we started with this tension, right? A powerful brain and a fragmented toolkit. And the Model Context Protocol resolves that tension by creating this unified, persistent communication layer.
It does. That principle of standardization and centralization is the golden nugget here. The MCP turns a collection of high-performing but isolated parts into a cohesive, highly effective system.
And that leaves us with a really interesting final thought.
It does. And it raises a question for you to consider as you look at your own tools and workflows. What other tech components or data protocols that are currently working in isolation in your business could benefit from this exact concept? From a unified communication layer to unlock massive parallel efficiency and scalability you haven't even tapped into yet.
Yeah, think about your own internal workflows. Where are you personally acting as the Model Context Protocol? Manually bridging two systems, translating context, wasting your own cycles on that organizational overhead. Finding that central point and automating it could revolutionize your efficiency, just like it did for these LLMs.
A great way to put it.
Thank you for joining us on this deep dive into the structure that powers modern AI orchestration. We'll catch you next time.